I mean, come on, the average was a 72. You would change something. Would you study more, start studying earlier, study something different, focus on the calculations, focus on the definitions, do everything exactly like you did? Read the book, okay, so that's good. If you didn't have a chance to read through the book, I mean, I don't, and that's a good point, because I don't have you buy a book and spend all that money to not look at it. I know with some classes you don't, it doesn't help any, but I think in this class, if nothing else, maybe we cover the same things in the slides, but it just helps you put it in the proper context if you read the chapters. Okay, so that's a really good point. Anything else that you would change if you were preparing for the test? Okay. Okay, so start studying a little bit earlier. Okay. All right, so, and again, when it comes to test 2, now test 2 just covers 2 chapters, chapter 5 and chapter 8. But they're 2 fairly large chapters. I will tell you, chapter 5, time value of money, which we're starting today, this is the most important chapter that we're going to cover all semester. You have to understand chapter 5 if you're going to understand chapter 6, chapter 7, chapter 9, chapter 10, chapter 11. I mean, you have to understand this, okay? So we're going to spend probably today, Thursday, and next Tuesday in this chapter. Okay, we'll spend at least 3 days here because this is really important. Now, what I'm going to do after this chapter is I'm going to put I think it's probably going to be a Tegrity video on Canvas covering part of chapter 8. Because I'll go ahead and tell you right now, I think I told you this maybe earlier in the semester maybe, but I'm going to be out of town a few days starting at the end of next week, okay? So we are not going to have a physical class on, let's see, next Thursday, which is going to be the 29th, I think, or the following Tuesday before your fall break, which is going to be, I don't know what day that is. But the 29th, the following Tuesday, and then the following Thursday, of course, is your fall break, which I think maybe is the, 5th? Something like that, 6th? I don't know. But so you get a pretty good break in between. But again, I will post some videos on Canvas. It's not like you're off just scot-free, but it's going to be a lot better than having to show up in class and listen to me in class. All right? And again, I'll remind you of that as we go along. All right, so chapter 5, time value of money. Basically, I mean, like I said, this is going to be the most important topic that we cover all semester. You have to understand how to do this. And the great thing about chapter 5 is not only are we going to talk about things that you can use when you go to work, but also we're going to talk about things that you can start using right now in your personal financial lives. Things like investing, saving, if you work, participating in your 401k plan, if you need to borrow money to buy a car or buy a house, how do you get the best loan? How do you calculate interest payments and loan payments and that type of thing? So we're going to cover a lot of information here. And basically what we're doing is we're going to be taking, when we talk about time value of money, we're going to be taking money forward in time, which is called future value, and we're going to be taking money back in time, which is called present value. And we're going to be using 3 different methods. We're going to initially look at formulas. I know a lot of you don't like formulas. We're just going to look at it for presentation purposes and to help you understand what you're putting into your financial calculator when we get to that. We're going to look briefly at a time value of money table, but primarily we're going to be using your financial calculator. Okay? And by the way, does anyone need to borrow a financial calculator? I have 3 that you can borrow for today. I just need them back. There was one more somewhere. Now, if you're doing this in the online class, of course, you can use a financial calculator. All of my examples are going to be using the BA2 Plus, the Texas Instruments BA2 Plus. You can use the TI 85, 86, 89, 91, whatever. And I would encourage you when we're in class that if you don't understand something, first off, if you don't understand what I'm doing with the calculator, please just stop me. Stop and say, I don't know what's happening. I'm not giving you the right numbers. Can you go over that again? That's not a problem, okay? That's not an issue. That's called learning. If you have one of the big graphing calculators and you are confused about, what am I doing? Where do I go? That type of thing. I would suggest, first of all, if you go to YouTube, there are dozens of YouTube videos on using the TI 85 or 87 or whatever it might be. Just type in TI 80 whatever in finance, and it will show you how to use your graphing calculator. And once students learn how to use that big calculator, they tend to like it better because you can see all of your variables on the screen. The screen's bigger. Also with the BA2 Plus, there's dozens of YouTube videos out there on how to use the calculator. But we're going to walk through step by step. Also, if you're in class and you don't understand something, look around, find somebody else who looks like they know what they're doing, and get up and go over to them and say, hey, can you show me how to calculate future value of a lump sum, present value of an annuity, whatever amortization schedule, whatever it might be. That's not an issue whatsoever, okay? All right, so as you're reading through chapter 5, and we've already established that it's probably going to be a good thing for you to read through the chapters, you're going to see a lot of things that look like this. These are called timelines, and timelines are actually really helpful when it comes to time value of money because it allows you to see what's happening with the different cash flows, with the different dollar amounts. For example, this is a 3-period timeline. It starts with time period 0. Time period 0 is today, okay, right now. And what we're doing is we're taking, in this example, we've got time period 0, this is time period 1, 2, and 3. Now these can be weeks, months, typically we assume they're years. So this is 1 year in the future, 2 years into the future, 3 years into the future. And we're depositing, in this case, $700, which is our present value today. We're earning 10% per year, and this shows us on our timeline what's happening each period with our dollar amount. So you're going to see lots of different timelines in your book. Okay, some taking money forward, some taking money back in time. But I just wanted to bring this to your attention. Now, as we're looking at different types of calculations, we're going to look at 3 major types. We're going to look at a lump sum, and that's going to be, a lump sum is also known as a single dollar amount. So that's just one amount of cash. Okay, so whether it's $100 or $1,000 or $1 million, it's just one lump of cash. We're also going to spend some time working with annuities. An annuity is, you can see the definitions here, it's more than one payment or more than one cash flow. They occur at equal intervals, so each week, each month, each year, and they're the same dollar amount. So for example, if you deposit $50 per week into your savings account each week, that's an annuity. They can also work for payments. If you have a car payment of $214 per month for 48 months, that's an annuity. Same dollar amount, equally spaced, and there's more than one. And we'll get to this later. We'll talk more about this, but there's 2 different types of annuities. The one we're going to use the most is called an ordinary annuity. That's where the cash flow or the payment occurs at the end of the period. Sometimes we will deal with what's called an annuity due. And that's where the cash flow occurs at the beginning of each period, the beginning of the week, the month, the year, whatever. And then finally, sometimes we're faced with what's called uneven cash flows or a mixed stream of cash flows. And so what that is, there's more than one cash flow, but they're not equal. So they don't fall into the annuity category. So we'll learn how do we calculate future value or the present value of this mixed stream of cash flows. So these are going to be the 3 that we start with, and we're going to start with the lump sum. That's the easiest way to start. And we're going to start with future value. And the reason for this is I think it just makes a little more sense to most students Because a lot of you, for example, have a bank account. You have a savings account. And you know that if you put money in today, it's going to earn interest and it's going to be worth more next week or next month or next year. All right, so we're going to use future value. You see the definition at the top of the screen. It says future value uses compounding to determine the value at the end of a project's life. Now, this word project, that's just a generic term. We could interchange there investment, security, lots of different things, asset. Okay, so it's just an investment, it's a dollar amount, whatever it might be. Now, compounding is the key to future value. And compounding is something that if you understand this, if you will just grab hold of this compounding idea and let it work for you, you can use it to your advantage. And in several years, you can be a very wealthy person if you understand compounding and you let it work for you. If you understand compounding, also when it comes to borrowing money, you can let it work for you. You can save yourself tens of thousands of dollars in interest. But if you don't understand compounding, one, you typically don't start investing early enough, and two, you start borrowing money for things like a house, and you let compounding work against you, which means you're going to pay an extra $100,000 in interest on your home loan, where you can have that $100,000 in your pocket or in your retirement account, whatever it might be. So compounding is simply, this is the simplest way, interest earning interest. That's what it is. So it's letting your money work for you. This is the timeline that we looked at earlier. And so what you see here is when we put in $700 and it's earning 10% interest, at the end of the first year, we have our $700 plus the $70 in interest. So now we have $770 in the account. And then we start earning 10% interest for the second year, and we earn an additional $77 in interest. Now, why do we earn more interest in the second year than we did the first year? Okay, so we started out with a larger present value, or we let our interest from the first year earn interest for the second year. Interest earning interest, compounding. And it may not seem like much here. You look at it and you go, wow, there's $7 more in there after the second year, big deal. That's true. After 2 years, it doesn't make much difference. But after 20 years, or 30 years, or 40 years, it does make a huge difference. And I hate to be the one to break it to you. We've talked about this, I think, the very first day of class. But most of you, if you graduate from college in your early to mid-20s, most of you are probably going to have a 50-year working career. 50 years, 5 decades, 1/2 of 1 century you are going to spend working. And hopefully maybe saving a little bit. Because keep in mind, life expectancies are increasing all the time. I'm not sure if that's good or bad. Okay, I mean, it's great to live longer, but I don't want to live to be 112 if the last 20 years of my life I'm hooked up to machines and I don't have very good quality of life. Okay, but Social Security, you hear people talk about Social Security. Most of you aren't going to qualify for full Social Security until you're probably, they're just going to keep pushing it back. So you'll probably be in your early 70s when you get to that point, even if Social Security is around at that point before you qualify. Because again, people are living longer. You're going to have to be paying in Social Security for somebody like me, okay, who retires before you and starts earning Social Security. So get really good jobs, make lots of money, pay lots of Social Security. So you have a long time to invest. So we're going to look at some long time periods. And you're thinking, a lot of you think, well, gosh, that's 20 years into the future, 30 years into the future. I don't know what I'm doing next week, much less in 30 years. Well, I understand you don't know what you're doing in 30 years or 40 years or 20 years. But if you would just start putting some money aside, you can worry about the other parts of life but that money's just going to keep working for you and building. And this is not about, as we go through this and we talk about sums of money, a lot of people think, well, what he's talking about is I have to have a lot of money to be happy. Okay? That's not what I'm saying. That's the last thing I'm saying. Believe it or not, and as a college student, this is really hard to believe, but a large sum of money by itself is not going to make you hurt. And you're sitting there saying, man, you're full of crap, okay? If I had a large sum of money right now, I'd be a lot happier sitting in this class than if I'm a traditional college student with no money. And I understand that, okay? But again, what you'll notice is as you go through life, things like your family, your friends, your faith, hobbies, your job, hopefully, those things are going to make you happy. Now, if you have $1 million sitting in an account somewhere, that doesn't hurt things. Okay? So I'm not saying it's a bad thing. I'm just saying don't count on money making you happy, but you have to look out for yourself. So we're going to try to kind of find a nice medium in between there. All right, so as we're looking at compounding, this is your first formula. And this is where a lot of students panic in this class. And they're like, oh, wait a minute, that's a formula. I'm not good with math. That's okay. You don't have to be good with math. Okay, I'm just going to use this to explain what you're entering into your financial calculator. Now, what this says is, it's the future value of a lump sum. And this says the future value at time period N. Time period N is just any period in the future. It could be 1 year, it could be 10 years, it could be 50 years. Is equal to the present value, that's how much we deposit today or invest today, multiplied by 1 plus R. R is the interest rate or the rate of return that you're earning on your investment, raised to the nth power. Again, N is the number of periods in the future for which you're calculating the future value. So 1 year, 2 years, 10 years, 20 years, whatever. And all you're doing is just plugging the numbers in and doing the math. It's pretty simple. You will be given this formula on your test 2 formula sheet, even though you may not use it. You will have it. And so one good thing about it is, even if you're working with your financial calculator, which is what you're going to be doing almost 100% of the time, you could look at this formula if you forget what to put in your calculator and go, wait a minute, I need 3 things for my calculator. I need a present value, I need an interest rate, and I need a number of time periods. That's what you would put in your calculator, and you would compute the future value. So that's mainly why I provide it for you on the formula sheet. Now, a lot of times when people look at the formula, they look at the notation, they're like, wait a minute, that confuses me. They're not numbers there, they're letters there. Well, let me tell you what the formula is actually doing, okay? We're going to break this down into really simple terms. So it says here that we want to find the future value of $700 invested for 3 years, earning 10% per year. Well, one way that we can do this is we could just calculate it year by year. So the first year, we take the $700 multiplied by 1 plus the interest rate that we're earning, 10%, 0.1, raised to the first power, which we can just skip this, but we can just leave it out. So at the end of the year, we have $770. The second year, we start out with our money that we made the first year, $770, multiplied by 1 plus the interest rate. At the end of the second year, we have $847. And then for the third year, we take our $847, multiplied by 1 plus the interest rate, and we end up with $931.70, which is the answer to our question at the top of the screen. Now, you could do that for any future value of a lump sum question. But the problem is, what if you have a long period of time? What if you have 30 years that you're calculating? It's going to take a while to do this 30 different times. So why don't we simplify this a little bit? Why don't we take these first 3 years, and rewrite it as our starting amount, $700, multiplied by 1 plus the interest rate for year 1, multiplied by 1 plus the interest rate for year 2, multiplied by 1 plus the interest rate for year 3. And we can simplify this. Why don't we rewrite this as 700 times 1 plus 10% raised to the third power. So now, for my math people out there, is this correct? Am I writing this correctly? Okay. And so if we do this, take 700 multiplied by 1.1 raised to the third power, we're going to come up with 931.70, which matches what we found calculating this one period at a time. Also notice how this looks very similar to this. So what this formula does, it just takes all of these calculations, these one period at a time calculations, it simplifies it. It utilizes the exponent, and we just plug in our information, so it would just be the 700, which is our present value, multiplied by 1 plus the interest rate, which is 0.1, 10%, in this case, raised to the third power. So that's all this does, is it just simplifies our life. So don't let, when you see this, don't think, wow, that's the hard way to do it. It's actually making your life a little bit easier. It's just doing all of this. Now, this is if we plug the information in. So we've taken our $700, our 10% interest, we have plugged it into our calculator. If you take 1.1 raised to the third power, it should be equal to 1.331. Multiplied by 700 equals $931.70. Now, if you have a new calculator, let me show you with the BA2 Plus. You're sitting there and you're looking at it and you're going, wait a minute, I'm not really sure how'd you raise that to the third power. Let's make a couple of changes here. The first thing that I want to do, now this is what you're going to see a lot, okay? This is just my little flash drive version of the Texas Instruments BA2 Plus. You will notice all of the buttons are in the same place. They're labeled the same. It should be exactly like your Texas Instruments BA2 Plus. The first thing I want to do is change to 4 decimal places. Okay, it's on 2 right now. So if you just bought your calculator, it's probably set on 2. So what I'm going to do is you notice right above the decimal, you see the word format. So we're going to use our second key to access anything above our normal key function. So I'm going to press my second key one time, and I'm going to press my decimal. It says DEC equals 2. I want to change that to 4. So I'm going to press the number 4 key. And then it tells me at the top of the screen I have to press the Enter key to lock it in. Now the Enter key is not, let me say it again, is not the equals key. That's where everybody wants to go. They want to go to the equals key. The Enter key is found on the top row of keys, second from the left, in big letters. Enter, E-N-T-E-R. Press that. You'll see it. Now it says DEC equals 4 point and 4 zeros. And now if you press your clear key in the bottom left-hand corner a couple of times, you should see 0 point and then 4 zeros on your screen. Everybody, that worked for everybody. If it didn't work for you, let me know and I can go through it again. So we'll have it set to 4 decimal places. We'll typically round to 2 decimal places, okay? Now, the other thing is, okay, now this was our problem. The exponent function, if you're going to square something, here's your square key, okay? So if you just want to square, 4 squared equals 16, that's not a problem. But if you're going to raise something to the third power or the 7th or the 28th, we're going to use the y to the x key, which is here, right above your number 9 key. So what I would do here is I'm going to put in 1 plus, so it's going to be 1.1, 1.1, well, 1.1. Then I'm going to press my y to the x key. I'm raising it to the third power, so now I'm going to press the number 3, and then the equals button. And it should say 1.331. So that is raising 1.1 to the third power. And then now we're going to multiply times 700 equals 931.70. And so you can do this whether you're raising something to whatever power we need to, as we'll go through an example in a minute. You can work through that. Now this is just using the functions of a calculator. This is not the time value of money function. It's just the basic calculations. Is everybody with me to this point? Pretty simple, pretty easy. Pushing buttons on the calculator, you learned that in 3rd grade, so I need to move on. Okay. It's going to disappear for a few minutes. It'll be back. Now, this is your time value of money table. I know this is small, and you don't actually really need to see the numbers here, but let me explain what it is. What this is, typically you have these in almost every finance book, although I think they've started kind of leaving them out of some books because people are going to either calculators or Excel. Excel has some really, really good time value of money functions built into it. So present value, future value. If you're in the online class and you like Excel better, it's got some really, really good functions that you can use for these calculations. What you see here, this is the future value of a lump sum table. So across the top of the table, you're going to see interest rates or rates of return. On the left-hand side of the table, you're going to see various periods. And this table goes from 1 to 18. What this does is it simply takes this, let's see, well, let me go back to the formula real quick. It takes this part of the formula, the 1 plus r raised to the nth power, and somebody has just gone in and says, okay, what is 1 plus 1% raised to the first power? What is 1 plus 1% raised to the second power? What is 1 plus 2% raised to the first, second, third, fourth, fifth, sixth, 10th, 18th power? And they filled those numbers in the table. So they've simply gone through and calculated the 1 plus r raised to the nth power for you. So if you take a look at the table, what you'll see, there's just lots of numbers here. So in the example that we just went through, and this 1 plus r, this is called what the future value interest factor, the FVIF. And so if you're calculating this using the table, you would simply take your present value, which in our example is 700. You would go across the top of the table to 10%. You would go down the table to time period 3, and you would look for the number there. And you would multiply the 700 times the future value interest factor. Now, let me point this out. And I should change this. I just keep forgetting to. In the formula to represent interest rate or rate of return, I use a lowercase r, typically. Here, this lowercase I, it also represents the interest rate or the rate of return. The difference is simply I copied that from another, I think from another slide. And what happens is when somebody writes a finance textbook, they want to be a little different from other people who write finance textbooks. And so to represent the interest rate or the rate of return, some authors use a lowercase r, some use a lowercase I, some use a lowercase letter k, some use uppercase letters. But when you see this I, it means the same thing as the r. It's the interest rate. And so in doing this, we would take our 700, we go to our table, we go across the top of the table to 10%, down to time period 3, and we're going to see the number 1.331. And if we take our 700 and multiply by 1.331, we're going to have $931.70 as the future value, which is what we found to this point using each year, step by step, the formula, and now the table. Okay, so we're doing pretty well so far. All right, now the next thing is your financial calculator. So this is what we're going to be dealing with a lot in this class for the rest of the semester. Now, I want you to check a few things with this. The first thing is setting it to 4 decimal places. Okay, so you should have that done. If not, this will walk you step by step through how to set it to 4 decimal places. Okay. The next thing is I want you to take a look at your payments per year, P/Y. Now, your payments per year are found right above. Now, let me say something about this. This row of keys where it says N, I/Y, PV, payment, and future value, this is your time value of money row of keys. So this is what you're going to be dealing with. Typically, you're going to be entering 3 of these. You're going to be solving for a 4th. But notice right above the I/Y, which stands for interest per year, it says P/Y. That stands for payments per year. So I want you to press your second key one time and then your I/Y key. Now, we want it currently set to 1. Yours may be set to 12, it may be set to 6, it may be set to 2, whatever. We want it set to 1. So if yours is not set to 1, we're going to press the number 1 key and then the enter key. Notice it tells us here, press the enter key to lock it in. Now, what this means, this little symbol here, this means you are finished. You can't go any further within this particular function. Okay? So now we're going to press our clear key, and you'll get in the habit of this. You'll just, you'll work a problem, you're like, wait a minute, what did I leave it on? Second. Okay, I'm on 1 payment per year. Because in this class, you're either going to have it set on 1 payment per year or 12 payments per year. That's it. 1 or 12. And we'll talk about monthly and 12 payments per year a little bit later. All right, and then the next item I want you to check is you need to know how to clear your calculator, your Texas Instruments BA2 Plus, after each problem. Because what happens is when you enter a present value or a future value or an interest rate in your calculator, that number stays there until something either goes over the top of it or you clear out your time value of money function. So again, this is going to become just second nature to you when you finish a problem. What you're going to press is you're going to press the second key and then the clear time value of money key, which is right above the future value. Then you're going to press the second key and the clear work key, which is your clear button in the bottom left-hand corner. So let's say I've got my calculator here. I've just worked a problem. Now, the first thing you do is you get back to zeros. Clear back to zeros first. So I've just finished a problem. I've cleared back to zeros. Now I'm going to press my second key one time. Then I'm going to press my future value key to access the clear time value of money function. And I'm going to press my second key one time again. And I'm going to press the clear work key in the bottom left-hand corner in that order. Now I'm ready to work another problem. And you're sitting there thinking, well, that seems like a lot of trouble. Well, it's actually not, because what you're going to do is you'll just finish a problem. You'll just hit second, clear time value of money, second, clear work, and you're ready to go. This is the major issue when students aren't getting the right answers. This is almost always is they're not clearing out their calculator correctly, and some old input is still in your calculator, and you're getting some really odd numbers, and you're thinking, why is this happening only to me? Well, it's not just happening to you, it's happening to a lot of people. So again, go through the clear process. Now, let me point out one thing. I see a lot of you, you're working your calculators really hard, okay? And so when I'm tell you to press the second key, I see a lot of you, and you just start pressing the second key several times. And then you'll go over to future value and press it. The problem with that is, notice if I press my second key one time, you'll see the little second show up here, and I'm accessing the function at the top of each key. If I press my second key twice, if I press it again, that goes away. So if you just start pressing your second key a few times, you could wind up here, which is where you want to be, or you could wind up here, which means if you press the future value key, it's not going to do anything associated with clearing time value money. Okay, so again, just second, clear time value money, second, clear work, and we are ready to work another problem. All right, now, as we're entering information into the calculator, as I said earlier, we're going to enter 3 variables. We're going to solve for the 4th. It doesn't matter what order you put them in. As long as you have 3 variables, you can solve for the 4th. And that's what makes this the calculator such a great thing, is because if you have to solve for something besides future or present value, you don't have to start using algebra to solve for the interest rate or the number of time periods. You can simply put in the 3 variables you have and solve for the 4th. Now, as we take a look at this, this is the problem that we just looked at. We've worked it 3 times already. the $700 deposited for 3 time periods at a 10% rate of interest. So let's use our financial calculator to calculate the future value of this $700. Now, this will walk you through, and I'm going to explain this in a minute why we're putting in a negative number here. But let me bring up my calculator. The problem is I can't keep the presentation on the screen where it's larger and bring my calculator up, so I have to do it this way. Okay, now here are our inputs. It doesn't matter what order. So I'm going to put in my N, which is 3 years into the future, so 3, then I'm going to press my N key. In the formula, our interest rate was a decimal. For the calculator, it's a whole number. So the 10%, I'm going to put in 10, and then press the I/Y key, interest per year. And my 700, now it says it's negative, so I'm going to put in 700. Now to make it negative, we're going to use this key, the plus minus key. It's not the minus key here, it's down here at the bottom. If I press it, it's going to make my 700 negative, and then I'm going to press the PV, the present value key. I've entered my 3 inputs. Now I want to compute, so I'm going to press the compute key in the top left-hand corner, and I want to compute the future value, FV. So the future value of 700 deposited for 3 periods at 10% is $931.70. So did everybody get that answer? What about my big calculator users? Anybody get the right answer? Anybody figured it out? You did? We got a genius back here, okay? Anybody who's not getting the right answer, come back here, pink shirt. He will show you how to do it, okay? I mean, like right now. Just get up and go to him in droves. He will help you do it. I think he's injured, by the way. Yeah, he can't even get up and move to you. He's got a hurt leg. All right. Everybody with a BA2 plus, right answer? Pretty simple. Now let me explain to you why we enter this as a negative. For your calculator, cash flows either have to be positive or negative. One of the two. And so think of a positive cash flow as cash coming out of your pocket, positive cash flow, cash going into your pocket. A negative cash flow is you taking money out of your pocket and investing it or spending it. So to be technically correct, this $700 that we deposited was a negative cash flow to us. It's money we take out of our pocket to deposit for 3 years. And then when we take the money out 3 years later, it's a positive cash flow, $931.70. If you understand that, you can skip this negative thing here. Typically, if I were going to work this problem, I would just have put in the 700, press the present value key, and compute future value. That's how I would have worked it. But then you see this and you're going to say, whoa, wait a minute, why is that a negative number? Okay, so I wanted to explain to you, if you take a shortcut and don't enter it technically correct like this, just understand this is your solution, but it's not a negative number. It's just you reverse things with your calculator and the cash flows. Everybody follow me there? Now there will be a time in this chapter where it does matter if a cash flow is positive or negative, and it has to be entered correctly, but we're not worried about that right now. Okay? All right, so this is future value of a lump sum. All right, so let's work an example. Might be realistic, probably not realistic, but anyway, we can have some fun with it. In our example, you have just graduated. I mean just graduated. You're still in your cap and gown. You're standing outside the CFSB Center. Your family's gathered around. They're so happy. And let's say, for example, you have a wealthy relative. And this wealthy relative comes up to you and they get their picture taken with you, and they're like, oh, I'm so proud of you. You survived Finance 330. You graduated from college. I want to reward you with a gift. But you have 2 choices. You have to make a choice. One choice is, I will give you a $15,000 trip to Europe. You can leave next week. $15,000. The second option is I'll give you $15,000 in cash. But if you take the cash, you have to invest the cash for a minimum of 20 years. You can't touch it for 20 years. Make your choice. Do what? Okay, so we put it in a bank account, and you can invest it however you want to. You put it in a bank account, you can put it in a stock market mutual fund, you can put it in government bonds, you can do what you want with it. This is not going to be continuous. It will assume it's going to be compounded one time per year, so annually, for 20 years initially. Now, this is the kind of problem most people like to be faced with, because there's no wrong answer here. You want to go to Europe? Go to Europe. I highly suggest it. Okay? It is just a valuable experience to get out of this country and see other countries and experience other lifestyles. That is worth a lot. And I highly encourage students, if you have a chance to study abroad or travel abroad, to do it. But also, it's pretty nice thinking, I got $15,000. Now, the problem with most of us is you can't touch it for 20 years. You could go to Europe next week. But what I want you to take from this, as we go through these examples, what I want you to take from this chapter is a lot of times there's not really a right or wrong answer if you've got a couple of choices like this. Is I want you to make an educated financial decision. What am I giving up if I take the trip to Europe? Or what am I giving up if I take the cash? Do you have another question? No? Okay. Okay, we're going there next. Okay? All right, so with this problem, oh man, I did not bring my, okay. All right, I left my bamboo in the office. Okay, so I can't write it out. So we're just going to we'll make this up as we go. All right, so for this particular problem, first of all, I'm going to clear out, and then I'm going to press my second clear time value of money, second clear work, to clear out any old cash flows. Now, if you are online, you can kind of see the numbers that I'm writing. If you're here in class, I'll put these on the board. We need three variables. We need a present value, which we know what that is. That is $15,000. We need an end, which we know what that is. That's 20 years. And we need an I/Y, which is the interest rate or the rate of return that you think you can earn on your investment over the next 20 years. Now, this is the big question mark here. That's just, it's always like that with investing, okay? Now, what I would suggest, if you're looking at something like this, first of all, you have to take into account your degree of risk aversion. Some people like risk, some people can't stand risk. So if you can't stand risk, and if you think, hey, if I put my money in the stock market, I'm not going to be able to sleep at night, don't put your money in the stock market. But in the bank, you're going to earn very, 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 very little interest, but that's okay. Sleeping at night is important. However, if you don't mind a little risk, and you've got a 20-year investment horizon, which that's what we call the time we're investing, 20 years is a long time. So over that 20 years, the stock market can go up in value, it can go down in value, it can go back up in value. But the stock market has averaged, over its lifetime, around a 12 to 13% annual return. 12 to 13%, that's pretty good. Now, that some years it's gone down. It's lost by 6, 10%. Other years it's increased by 5%. But we have to use an average. That's the best we can do here. So, if I'm thinking about this, if you invest in a stock market mutual fund that invests in all different types of stocks, maybe a growth stock market mutual fund or value fund, I would say a safe assumption over a 20-year period would be an 8% annual return. I'd be comfortable with that. Okay? If you think, well, I could invest a little more aggressively, maybe in some small cap mutual funds, you might want to put 10% here. Or maybe if you're more conservative, you might want to put 6%. But I'm going to use 8%. So we're going to put in 8. Well, let me go here first, the board. 8%. And we want another future value. So we're just going to enter our information here. Now, I've cleared it out previously. And I'm just going to put in my information here. So 15,000 is my present value. 20 is my N. And 8, the whole number 8, is my I/Y, interest per year. The last thing left is I want to compute. Press the compute button, top left-hand corner, future value. And so what this shows us is this $15,000 that you invested 20 years ago will be worth at an 8% average annual rate of return almost $70,000. So when you can touch it, it's worth $70,000. That's pretty good. Now, again, this is not about is the trip better or is the $15,000 cash better. It's simply about what are you giving up? Well, you'd be giving up $70,000 future dollars to take the trip to Europe. But don't take this as I'm anti-Europe vacations, okay? I'm not, or I'm anti-any. A lot of people, when they hear this, they see these examples, they think, well, what he's telling me is I shouldn't take a nice vacation. That's not what I'm telling you, okay? I'm simply telling you you need to be able to make smart financial decisions, and it's not all one or the other. A lot of people hear this and they think, okay, I have to save everything I make, or I'm going to save nothing. That's not it. What I want you to do is use common sense, use some restraint, save a little money, take nice vacations if you can afford it. But the long-term effect is you'll have money saved up, and you'll also can look back on your life and say, hey, I had a really good time. Okay? I've been able to travel, I've been able to buy my toys that I wanted, whatever the situation might be. Now, in this example, another great thing about your calculator is you can do some what-if analysis. You don't have to go through and start the problem over with. So in this example, if you listen to what I tell you in class, you find a career that you really love, you're 20 years out from graduation, I mean, you've still got a lot of time. You're in your early to mid-40s. You're still young, okay? I mean, I'm 48. Early to mid-40s is a lot younger to me now than it used to be. So you're not ready for the grave yet, okay, in your early 40s. So you're happy, you're making good money, you're participating in your company's 401k plan. You really don't need this money. So you're thinking, why don't I leave it invested for another, say, 10 years? And I'll check on it and see how much I have then. Well, this is where compounding really starts to work. So instead of N being 20, let's change N to 30. That's all we have to change is N. We don't have to touch anything else. So if I put in 30, and then press the N key, and now compute the future value. 10 years later, our $70,000, or $69,900 and something, has turned into almost $151,000. It more than doubled with just 10 additional years. Now somebody explain to me, how does that work? How much extra money, how much of our money did we put in that 10-year period? None. Okay, we put in the $15,000 30 years ago, and that's it. We haven't touched it since then. So how did this more than double with just 10 additional years? The secret word I'm looking for. It's been in compounding. That's exactly right. Interest earning interest. So this is after 30 years. Let's say in your 30s, you're in your early 50s. Again, that's not as old as you may think it is. So let's look at 40 years down the road. So 40 in compute future value. 40 years later, your $15,000 averaging an 8% rate of return per year is now worth $325,000. That's not bad for money you put in and you left alone. And then we could also look at 50 years. Again, you think that's a long time into the future, but for most of you, that's when you're going to be retiring. So 50 years into the future, you peek into this account. So we change 50 in compute future value, and your $15,000 that you received 50 years ago is now worth $703,000. And you can take a really, really nice trip rate, your retirement. This is not magic. It's not a trick. It's just compounding, interest earning interest. And you'll notice as the years increase, the numbers get exponentially larger. So think back to the formula, the exponent in our formula, that's what's happening here. We have exponential growth. And that's what the great thing about compounding. So if you have 20, 30, 40 years, that's when it really works. It doesn't do much in year 2 or 3 or 4. And that's what people who don't understand this, they expect that to happen. They want great things to happen in the first 5 years. It doesn't work that way. But you have to make it through the first 5 years to get to year 20 or year 30 or year 40. Now, we earned 8% on this investment. And again, that's a pretty good rate of return. And a lot of times when people are thinking about investments, and you shouldn't obsess over it, it's not worth spending every waking hour studying your investments, but you should be aware of it. And so let's say that you paid attention, and instead of earning 8%, you earned just 9% per year, 1 percentage point more, which doesn't sound like much. But if we earned 9% as our interest per year over 50 years for the $15,000, and we compute our future value, 1 percentage point more would mean we have now over $1 million in an account. You can now call yourself a millionaire, and that's based on $15,000 50 years ago. But again, no wrong or right answer. It's just you have the ability now to look at what if. What if I do this? What if I don't do this? That type of thing. Yes. Unless you're always given the interest rate. You're always given actually all 3 variables. Now, if you have to solve for the interest rate, I would give you another of the variables, but you can solve for the interest rate. Okay, so is everybody following this? I mean, this is pretty straightforward, pretty simple, pretty good stuff. Okay, now what I want to do, and this is something pretty realistic. Let's go through and clear everything out just to get in the habit of it, first of all. So press your clear button to get back to zeros, and then second, clear time value of money, second, clear work. And again, I wish I had something to write on here, but I don't, so I'll use the board. Let's calculate using what we've learned about the future value of a lump sum. Let's calculate what it's going to cost your child or children, what it's going to cost them to go to college. We can use future value, we can use time value of money for all kinds of useful things. Now, the time to figure out what it's going to cost your kid to go to college is not when they're 18. Okay? February of their senior year is not the time to sit down and say, okay, let's figure out how we're going to pay for you to go to college. You need to think about that the day they're born. Or as soon as you hear this lecture, one of the two. Because then you have 18 years, unless your child is a child genius and they're going to college at 12, you have 18 years to save up and utilize time value of money and compounding to help offset the cost of them going to college. You can put your money in something maybe like a 529 plan, which is just a college savings plan where you invest the money, you save it every week or every month or whatever, and it grows over the 18 years. Now, to calculate this, first of all, we need a present value. So the present value would be, how much does it cost right now to attend, let's just Murray State, a Murray State type university, a public state university. And I know there's different numbers for all of you. Some are out of state, some are in state, some have scholarships, some don't, some live on campus, some live at home. I know there's big differences. But could you give me just maybe a few estimates so I can just average it of what it costs for 1 year? That's everything. Books, food, tuition, transportation, clothing. Give me some estimates. What? 11,000. Good. What else? Anybody 15,000? Sound like an auctioneer up here. 16, 17,000. I mean, some are probably 11, some are maybe 15 or 16 maybe. Yes, no? I see some heads nodding. Anybody? So what would be a good average to use? 15,000? Okay, we'll use 15,000. Okay, so it's going to cost 15,000 today. This is our present value. N is pretty, well, N's maybe not so simple. I take that back. N is the number of years in the future until your child starts college. Some of you have children, so you can calculate that pretty easily. Others don't even have a significant other right now, okay? So you're thinking, okay, maybe it's going to be, I need about 7 years to find that right person. I got to date them for a while to make sure they're not some kind of person I don't want to marry. I've got to take a look at, we want to have some fun once we get married, travel some before the kids weigh us down. So it's going to take about 7 years. That's just my estimate, okay? For some of you, it may be longer. For some of you, it may be shorter. I don't know. I'm just going to go 7 plus the 18 years until they start college. I'm going to use 25 years as my end. And you can adjust the number according to your personal situation. Now, the last variable we need is the interest per year. Now, in this case, it's not really an interest rate. It's a growth percentage. How much is the cost of college per year? That's kind of hard to estimate. We know that it grows fast. Tuition's going up really quickly. 8, 9, 10% at some universities, 11, maybe 12% at some universities per year. On the other hand, the cost of living, the cost of food, housing, books are going up pretty quick. But the cost of living may go up at maybe a 3 or 4% rate per year. So if we average this and took, the cost of tuition increases and the cost of living, I would say we would be safe at assuming around a 6 to 7%, I'll use 7%, average annual growth in the cost of going to college. And maybe it'll be 5%. If it's 5%, that helps you out, okay? We'll use 7%. Wait a minute, it's wrong place. That's going to be here, 7%. Okay, so we have our three variables. $15,000 present value, 25 is in, 7% is our interest per year, or in this case, it's our growth rate. So I'm going to put this information in. 15,000 is my PV, present value. 25 is my N. And 7 is my I/Y. And I want to compute the future value. So what this, anybody else come up with this number? 81,411? Yes? Okay. What this tells us is, in 25 years, if college costs rise 7% per year, it's going to cost $81,411 per year per child to send them to a Murray State type institution that currently costs $12,000 Oh, they cost $15,000 per year. We can simplify it. We'll just drop it down to 80. If they're on the 4-year plan, 80 times 4, it's going to cost $320,000 for one child to go to college, if they're on the 4-year plan. Now, if they're on the 5-year plan, it's going to cost, we'll just use 80 times 5, $400,000 per child. The numbers you see in front of you and your eyes get kind of big and you're thinking, wow, that's a lot of money. That's the reason your parents freak out whenever you call home and say, guess what, Mom and Dad, I'm changing majors. It's going to take me an extra year to graduate. What they're seeing is, they're seeing what college cost 25 years ago, and the $15,000 to them is the same as $81,000 is that you're looking at now to you. They're like, oh my gosh, another year of college, if they're paying for it.
How much did college cost?
I have no idea. It was a lot less. It was a lot less. I think I paid my first year's tuition. I paid a dozen eggs and 4 chickens, I think, or something like that. No, but it was a lot less. But again, this gives you an idea of what's it going to cost, because you see this and you think, that's a lot of money. But I would rather see this now, knowing you can start investing to help offset this cost, rather than your child be a senior and you're saying, how do I pay for it? Okay? Now, this example, this is my contribution to controlling the world's population. Because I know some of you out there and you're all in love and you're thinking, okay, I'm going to get married, I'm going to have 6 kids, and we're going to educate all of them. You see this example and you're thinking, I don't know if maybe 2 kids is enough, okay? Maybe we can get by with 1, okay, maybe. But again, keep this in mind. This is at a public university. Let's say, for example, your child is going to be too good to go to a public university. You had to go to Murray State, but by golly, your kid's not. They're going to an Ivy League school. Well, we can calculate the cost of that too. We can simply take the $15,000 and we can change it to about $50,000 as our present value. Everything else will stay the same, and we can compute the future value. And we can see that if you want your kid to go to an Ivy League university or a private university, it's going to cost in 25 years around $271,000 per year. So we can just round it off at a flat million per year for 4 years. Excuse me, $1 million over a 4-year period total. This is why planning early, having a child genius, or having a really, really athletic child are necessities. One of the 3 has to happen. I would count, until you know how smart your kid or how coordinated your kid is, I would count on saving money for their college education. You can always spend it on something else if you don't need it, okay, for their education. Everybody have a good day. I will see you on Thursday when we finish this, or we continue with chapter 5.